Welcome to the MSJC Internet Authoring Videocast.
Welcome to CSIS 113B, Lecture 7. In this lecture, we'll be covering methods. We'll talk about how methods communicate with objects, how to go about creating simple methods, setting up method headers, also known as signatures, declaring methods, invoking methods, also known as calling methods. We'll talk about what's this, which is a special keyword that we'll use to reference the members of a method. Value-producing methods, which are methods that return a value to the caller. Passing arguments to methods, which is the caller sending parameters to the method. Declaring a method's formal parameters, which is in the creation of the method signature. You'll need to define what parameters it can accept. We'll talk briefly about the SOLID Principles of Object-Oriented Design, focusing in a little bit on coupling and cohesion. We'll also talk about variable scope, because the availability of your variables is going to change as you put them inside of methods. We'll also talk about overloaded methods and about creating one code path. So methods, also known as functions or subroutines, are like small programs within a program. They're designed to perform a specific task. So in object-oriented programming, methods perform tasks that are related to the members of the class. They operate on the data section of the class, which is known as the field variables. And you have already been using methods. The scanner class and the random class would be examples. For the scanner class, you've used its next line method and its next int method. Also, you've used a method from the random class as well. And we'll talk a little bit about what's called a constructor method, which is when you're creating new classes. It basically defines on what parameters the class will accept. And for a little bit more in-depth information, if you're interested, I have a link down there at the bottom for Java constructors. So that just takes you to a web page that gives you a more in-depth look at that. So communicating with objects is what we're talking about here. So to invoke or call the method, a method of an object, you send the object what they refer to as a message. And really what it is just simply calling the object and then identifying which method you want that object to run. So we give you an example here, a statement where we're creating a value, a variable named value of integer type, and it's being assigned then the results of calling the next int method from the rand instance of a random object. So that message then in this case is next int. So, it's a method within the class. It's also, you'll hear it referred to as sending a message to the object. I prefer just to refer to it as calling the method within the object. So the receiver and the message, when we're doing a reference to them in our programming statements, will be separated by a dot operator. This is known as dotted notation. So again, you can see we have the example of the integer type value being assigned the results of running the next int method with a value or an argument being passed to it, a value of 100. That's the argument that we're passing to it. So when you're calling methods, you pass arguments to the method, or you send an argument to the message, one could say. And then the receiver is the instance of the object itself, which in this case is RND, which is an instance of a random object. And of course you know by now that generates a value between 0 and 99. It always starts at 0 unless we shift it, and the value in the parentheses is identifying how many values will be returned within the random number, not at a single time, but what the range is of values that are possibly being returned from a random number. So to kind of visualize a little bit about what's going on here, when we're calling a message. We can take a look at this animation here. So you've got the code that's been written previously for the random class. And so the way that we illustrate that in our own program is we use the import statement to identify the fact that the compiler needs to import that particular class and have it available for our program. And so it does just make a copy of that random class and it stores it in our program's heap memory. Then we create an instance then of a random object using the new keyword. So you've seen this before, just simply identifying the data type as random, creating a new variable called RAND, and then assigning it the new random, where we're calling the random class's constructor method. That's what when we put the parentheses there at the end of the class name, that's essentially what you're doing. You're calling the constructor method of that class. And so we're creating a new instance of it and assign it to the RND variable there. So that instance of the class now is being generated in the program, or whatever program we're writing, our heap memory for that program. And then you can see that it actually is pointing back to the random class. So the entire code of the random class is not copied into the random object. Only the instance variables and the instance methods of the class will be copied into our random object. So if there are static variables or static methods within the random class, they remain with the random class. And that's important to know because we're going to talk about creating static methods here in a little bit, or instance methods in a little bit as well. And so here you can see that the graphic just representing the fact that the static variables and methods remain within that random class, and then the instance variables and methods are contained within the code that's representing our RND object, and all of that's occurring within our program's heap memory. So we'll start out by creating a simple method. As we pointed out earlier, methods are called different things in other programming languages. You'll hear them referred to as functions or procedures or subroutines, and there's some others as well out there. But they all mean basically the same thing, which is that you've created a little program that can accept values or not. You don't necessarily always have to accept values with a method, and it may or may not return a value. But it runs a little bit of code, and then it returns the flow of control back to the caller of the method. Again, Java is an object-oriented programming language, so all methods have to be part of a class, and you've already done this whether you realized it or not. Whenever you created a class in a new class or a new project in NetBeans, it created a class for you, and then you built everything else inside of that class. If you think about the main method that's in all of the programs that you've built so far, so that's an example of a method that is inside of a class. And then as far as the structure of the method, we have what's called the method header. And so we've got some keywords there: public, void, and then the actual name that's being assigned to the method, which is foo in this case, followed by a set of empty parentheses. So that means that it doesn't accept any parameters. We'll get to public and void here in just a little bit. Then method body is just in a set of curly braces. So all your statements then that are going to make up this method, those will be enclosed inside of the curly braces. So from a technical standpoint, our method header contains an access modifier. So that was the public word that you saw in the previous slide there. So the options are public, protected, which is the default. If you don't put anything in there, it'll be protected or private. So protected means that the access level is only within the package and outside the package through a child class. So we create a child class of the class that we're working in. Public means that the access level is everywhere. So any code that is written that wants to call our method can have access to it regardless of the library that contains it. And then private would mean that the access level is only within the class. So only other methods or code within the class would be able to have access to call our method. The method name can be anything as long as it follows the naming convention rules. Additional information needed by the method to perform its task would be things like static, return type, and essentially static is a keyword that you would put in the header if you want to make it a static method. So if you remember back a couple slides when we were talking about the instance methods and the static methods, all methods are instanced by default. Unless you put the keyword static in the header, then that means it's a static method. And as far as the return type, if we indicate the word int, for instance, in the header, we would be identifying that this particular method that we're creating would return a value of int type. So we'll get into return methods, value generating methods here a little bit later on. Formal parameters, those are declared inside of the set of parentheses after the method name. So the example we saw just had an empty set of parentheses, but inside of those parentheses, and when we get to the example of methods that accept parameters, we'll talk a little bit more about that in depth. But essentially inside of those parentheses, you have to define what the data type and how many parameters can be accepted by the method. And then curly braces, as you saw on the previous slide, do delineate the method of the body. So all the statements that make up the method go inside of a set of curly braces. So here's another example here. You can see inside of a class called Lecture 7, we're creating a new method called Hello World. And it's being assigned public as far as its access method. It's void, so it doesn't return any return value. That's what void means. And again, the hello world is the name, and there's no parameters that it accepts. We have an empty set of parentheses there. So that's the signature or the header for that method. And just a simple statement then inside of the method body that prints out the hello world text to the screen. Now notice too that that method is not inside of the main method. So the main method is where, when your program fires off, that's where the initial flow of control is. Inside of main, you'll have some statement then that more than likely will call your hello world method. The hello world method will run and output to the screen the text hello world, and then return the control back to wherever we left off within the main method. So you can see here is an example then. Since this is not a static method, it's an instance method. In order to use this method within our program here, even though that it's public, you can see if you look down in the main method, we're creating actually a new instance of our class. So our class is Lecture 7, so we're creating a new instance of that. We're assigning it the name L7. So the type is Lecture 7, the name is L7, it's being assigned a new instance of Lecture 7. So essentially we're making a copy of our own class here in memory. Now that we have that instance, we can actually reference the method. We can call the method that we built here in our class by using the instance name of the class that we just generated, so L7, then followed by a dot, so L7 dot, and then the name of the method that we want to have run, which is hello world. Notice you call it by name, and you also will have the empty parentheses there, and then it's just a single statement, so you end it with a semicolon. I should point out too, when you're looking at the name, notice that that's in camel case because it's a two-word name. So we've got the first letter is lowercase, and then the second word, world, is uppercase. And that's pretty traditional in Java to use camel case for naming of your functions, or your methods. A little bit about the main method now. Your applications have to have at least one main method contained within them. You don't, or you can't have more than one, but you must have at least one. And the main method can be part of any class. In fact, it looks like it belongs to the class. That's sort of true and sort of not true. It is able to access the field variables directly. So that kind of implies that main is part of the class, but you need to create an instance of the class in order for main to be able to call any of its instance methods. Now, if you create a static method within the class, then main can use it without creating an instance of the class, and we'll show you that difference here in a little bit. So main, as you notice probably, and its header, its signature, is a static method. So it is part of the class, but it's not part of any objects. In other words, when we create an instance of the class, main is not a part of that instance. So the Java virtual machine can call it without having to create an instance of the class. That's because it's been identified as a static method. So what is this? Well, this is a key word that we can use to reference the current object and then the members within it. We use it when we're accessing other members of the same class. It allows us to use the same form of sending a message to an object. So if you look at the example here, we've got two methods that we've built outside of the main class. So going back to the previous example, we're still creating an instance of the class, and in this case now we're calling the new method that we created, which is the say hello method, and you'll notice that the say hello method, the statement inside of there, uses this keyword to then call the hello world method. So main has a statement that creates an instance of the class so that it can reference, because if you look at say hello, it's not a static class, so that means it's an instance class. I'm sorry, an instance method, not a static method, it's an instance method. And so that means in order for us to be able to use that within our main method, to be able to call it, we have to make an instance of the object, which we're naming L7, and then we're calling the say hello method from L7 in the last line, or line 13 there that you see in this example. Or passing a message to the object if you want to use that terminology. Like I say, I don't really use it all that much. I just refer to it as calling the method within the object. Now we look at value producing methods, which are methods that will return a value. So your program can have a method or methods that is capable of producing a value or return value. And that can be referred to then as an answer to the message. Again, that's not a terminology I prefer to use. I just say it's returning a value. In order for your method to be able to return a value, we have to identify in the header its return type. So you can see for letter A, the return an int type there in the example on the right. So this time it's a public method. It's adding the keyword int in there, or the data type would be a better way to reference that. So the type of variable that's going to be returned by our method, foo. And then internally in the body, you can see that we use the keyword return, and that identifies then the actual value that will be returned. And that could be an expression, it could be a lot of different things. This is very simple, just returning a simple int value. So anytime we call our foo method, we'll get a return from that, which will be the value 10. Here we have a valid producing method example. You can see that we've got this get value method, and it's being declared as public and identified that it returns an int value. So what it does is essentially create a new instance of a scanner object, asks the user to enter a whole number, assigns the value that the user types in to an integer value, and then we return value back to the caller of the method. So if you look down in the main method there, you can see, again, this is not a static method, so we had to create an instance of our class first, and then in the main method we create a new integer called num, and it's being assigned the returned value from the get value method. And then the last line there, the last statement is to just print the number entered is, and then whatever the value of num is. So the value of num, again, is whatever's the value being returned from the get value method. And then all the way at the bottom, you can see there's the example of running the program. We asked the user to enter a whole number, the value 6 was entered, and then the output from the program was the number entered is 6. Pretty basic stuff. So invoking the method or calling the method is just simply a matter of typing the name of the method in your program at some point. Usually, especially if it's a value producing method, you're going to take the results of running that method and then assign it to some other variable that you're going to use in your program, just like we showed you in the last example and in the example that's on your screen now. So the calling of the method, just if it's an instance method, it's always going to have the class name first, followed by a period, and then the actual method, or name of the method, with the empty parentheses. Now later on, we're going to get to where we actually pass parameters in those parentheses, but for now, that's the way that you want to have that framed in your head. In fact, here we are, passing arguments. So arguments, sometimes called parameters. The arguments are what we pass to the method. So that's basically what we're doing, is we're providing additional information to the method, and that information is going to be used or processed inside of the method. So those arguments are when we actually invoke the method, when we call the method. We're going to, in the parentheses of the statement where we're calling the method, we will actually put some value in there, so that one or more values that we want processed by that method. So parameters do come in two types. Formal parameters, those are the parameters that will show you are declared when you're defining your method. When you're declaring your method, you'll actually put those parameters inside of the parentheses. And so those are what we call formally stated, meaning that you have to specify the data type. So you're going to basically say like int num. That means that your method would accept an integer data type, and it would treat it with the variable name num internally in any statements that are going to process that incoming value. So formal parameters are in the declaration when you create the header for your method. Then actual parameters are these arguments that we were just talking about. So after you've created the method, then you're going to call the method somewhere in your program, and at that point you'll pass in values that you want that method to process. Now you only need to supply the data that matches the type and the order. So now you need to supply the data that is going to match both type and order in which they were declared in the formal parameters. So we'll look at that here in just a second. But they can be of several formats. They could be variables, they could be literals, or some sort of expression that produces the proper data type. So here is a parameters example. You can see the formal parameters being created at the declaration point of our sum numbers method here. So we've got a lot going on. Let's go through it. So we're inside of a class called console. We're declaring a method that's called sum numbers. Notice in the signature that it's identified as both public and double. So double means it's going to return a value of double type. And then in the parentheses for the declaration, we're identifying three different formal parameters that declare what types will be accepted. So in this case here, we're going to have three different doubles. The first value that gets passed into sum numbers will be considered or assigned the variable A. The second value that's passed into it will be assigned the variable name B, and the third would be the variable name C. So you can see this is a simple statement inside of the method. We're just simply adding those three values together and then returning that back to the caller. So that's why it's called sum numbers. It takes the numbers that we pass to it and sums them and then returns the results back to the caller. Then down in the main method, the main program flow of our program, you can see that we're initially assigning three different doubles, X, Y, and Z. So the first one, X, is being assigned a value of 3.1, Y is being assigned 2.2, Z 4.4. Then we create a new instance of our class. We call it C. And then the next line, we're assigning to a double variable named sum the results of calling some numbers and having it add those three values together. So notice that the actual parameters or arguments, they don't have to match as far as the name goes that we're passing into the method. The method will just take the order of those. So x is going to become A, y is going to become B, and z is going to become C. The main thing here is that it has to be doubles, double data types that we're passing into that method. So that is critical. The data type that we're passing in has to be the same. But as far as the naming, you can call them anything you want as far as your arguments are concerned. The only thing that really matters, as I say, would be the order that they get passed to the formal parameters. That's where they get assigned. In fact, we have an example of that coming up here. Starting with this slide here, we're talking about how parameters are passed. So parameters are passed by value in Java as opposed to a reference. A copy of the actual parameter is taken and passed to the formal parameter. So the actual parameter, that's the value that's being put in as the argument. And as I said in the example previously, it's then taken and passed to the formal parameter, the one that was being declared in the method. The stack is used for this process. So the variable that is the actual parameter, the argument, being pushed onto the stack first, the code branches then to the new method, and at that time the value that was pushed onto the stack is popped back off again and assigned as the actual or formal parameter. So it's a copy then of what was in the argument that was passed to it. So you'll see that here in animation form. So we've got this public int square method. So it takes in one value, int, or one parameter, int num. So it's got to be of integer type. It's going to use it internally as a variable named num. In the main method, just jump down below the creation of our instance console C, and you'll see there we're defining a new integer called the square, and that will be assigned the results then of running the square method when we pass in the value of x, and x was previously assigned there in main as a value of 3. On the far right, you can see is just kind of a primitive example, primitive representation of a stack memory area. So what's going to happen now is that first the value 3 is getting assigned to x, then we create the instance of the new console object called C. Then c.square, in that statement, we're calling that method square, and we're taking that value 3, which previously it just had an x there. Now it's taking the actual value of x, which is 3, going to move it up to the stack. So it's pushed onto the stack, and then it's popped back off again now that the flow has switched to the new method, which is the square method. The value 3 is being popped off and going to be plugged into the integer num there, the actual parameter, the formal parameter. And then inside in the statement, the two nums get replaced with that value of 3. They are multiplied, come up with 9. So the return value is created at that point. And then 9 is being passed. It basically goes back onto the stack, pushed onto the stack again, and then popped back off once the control, the flow of control is handed back over to the main method there. So it's returned to the main method now. The value of 9, you can see, is inside of the parentheses for c.square, and then that's assigned to the actual variable, the square. Another example here, miles per gallon. You can see that a method called mpg is created. It's going to return a type of double, and it also takes in parameters, formal parameters of two different doubles. One is going to be referred to as miles, the other is gallons. So internally it takes miles and divides by gallons and then returns that value. In the main, we create an instance then of the lecture 7. We call it L7. And then further down you can see that we've got a new scanner object being created. We ask the user to enter the miles first. It's assigned to the variable miles, which is of type double. Then we ask them to enter the gallons. That's assigned to the gallons variable, which is also of type double. And then we're going to assign to MPG, which is also of type double, the results of calling the instance object L7 dot and then the method MPG, passing to it the values of miles and gallons. That gets divided in the MPG method. The results of that gets returned, assigned to the MPG variable down in main. And then line 19, we're actually just outputting then the results of running that method with the text that says your average miles per gallon is, and then concatenating the actual value of MPG and then adding the string MPG after that value. So quickly, we're going to look at solid principles of object-oriented design. These have been around forever. And they're 5 principles essentially designed to help programmers write better code. And the 2 that we'll focus on here will be the single responsibility principle and the open-close principle. And if you want to get more into it, I've got a link to a YouTube video at the bottom, and then also a web page that explains the 5 first principles in a little bit greater depth. So when we look at SRP, the single responsibility principle, it just basically refers to the fact that a class or method should have one and only one reason to change, meaning that it should have only one job. If we don't follow this principle, it creates undesirable coupling or dependency. So what happens, you got to think about when you're working in a large organization and you're writing classes and methods, other programmers in that organization will also be using your classes and methods. And if a change gets made to that class or method that is unexpected, that can end up breaking a lot of other code that other people have written. So that's the dependency, is that their code is calling on your classes and utilizing your methods. That's their program's now dependent on the way that you've written your code. And then the open-closed principle basically states that you need to have the class or the method be open for extension but closed for modification. So technically speaking, you want to try and write code that doesn't need to be modified down the road, because again, that's going to cause some problems when people start using your code. And an example of violating the open-close principles, if you start having to write a lot of if-else statements. So I'll just try to give you kind of a quick example here. If you were using doubles in some sort of an accounting calculation method, and then all of a sudden management decides they don't want doubles to be used anymore, they want ints to be used instead. The problem is now you would have the other folks that were using your code, they're going to have to start writing if statements that say, well, if it's this particular type of data type, then go ahead and do this. If it's the other type of data type, so if it's a double, do this, or if it's an int, do that. And you can imagine that that's really going to add or creates just horrendous problems for large systems, large programs that you're building, if that's the case. And so that's why you want to try to limit your classes, your methods to basically just doing one job. And then this slide here kind of refers back to that, the terms coupling and cohesion. So cohesion refers to essentially that single responsibility principle. So how many things will your method do? Ideally, you want your method to perform a single task. Not always possible, but you should strive for it. And then coupling refers to the open-close principle, how tightly integrated your method is to your program. If the code is tied to the data, which means that you need to take the whole class, not just the method, that could be problematic as well. So just mainly want you to kind of be familiar with that terminology, because that comes up a lot when we're getting to the point when we start debugging programs or looking at designing programs. So here's a cohesion bad example. So how many things does this method do? So the method's called square. You can see that it basically creates an instance of a new scanner object, and then it prompts the user to enter a number. It assigns that number to an integer num, and then it also outputs the text the square of your number is, and then performs the mathematical operation num times num. So that's a bad example because you're both taking in the value as well as outputting the value within the same method. You'd be better off if you just split that apart. So here's an example of that, just creating a single method called square where it takes an integer num and then it returns num times num, and then your main program can do the rest of the work that you saw in the previous slide. Now another thing you'll need to be aware of is variable scope when you start creating methods. So a variable scope has to do where it can be seen or accessed and by what. So you should strive to make your methods as self-contained as possible. Use local variables, meaning you actually declare the variables inside of the method whenever possible. And these are the variables that are defined within the method. So local variables. So local variables, use local variables whenever possible. Local variables are being defined within the method. Field variables are the variables that you define within the class outside of any methods. So the field variables can be directly accessed and shared by all members of the class. So when you're creating classes in object-oriented programming, field variables are the attributes or the properties of the class. And it's very typical then that you create methods that are the only way that other users of your class can actually modify the variables stored within the class, the field variables stored within the class. So, until you really get writing more and more object-oriented programs, this may not make a lot of sense to you. So for the moment, just realize that if you create variables inside of a method, only that method has access to that variable by name. So in other words, if you go outside of the method, within the main method, or even another method within the class, they don't have access to those variables unless you pass them out of the method to the other methods. So variables that are created inside of the methods that are contained strictly within the methods, the local variables can only be accessed by the method where they're created. Variables created outside of any method can be accessed by any method within the class. That's the simplest way to recall that. So here's an example of local variables. So defined within the body of the method, as we just talked about, can only be accessed by other members of the method. So we've got a method A and we've got a method B. So in method A, you can see that we're calling the other method, method B. And then we're also assigning to a variable named A variable the value of 25. Or at least we're attempting to do that, because we can't do that. See, if you look at this, if you go down further now to method B, you'll see that the actual declaration of the A variable is in method B. So it's int A variable, and that's the first statement there inside of method B. So that's where that A variable exists, and it only exists inside of method B. Method B can go ahead and assign a value 3 to it, and that's no problem whatsoever, and print it out. But up in method A there, even though it called this method B, notice, is void. So it's not returning any value. It's doing its statement, it's doing its thing, but it's not returning any value to any callers. So up there in A, that's an illegal statement that would throw a compiler error. So in this case now it's been fixed. You can see that we've created the A variable twice actually. Now it exists inside of method A. The declaration for A variable is inside of A, and then you also have a declaration in B. And that's perfectly acceptable because they are local variables. Even though they're the same name, there's no conflict there. because of the way that the compiler sees it is, well, the first A variable, that only belongs to method A. And the second A variable, well, that only belongs to method B. So there is no conflict there at all. So if we assign the value of 25 to that first A variable, that's what that value is for the A variable as long as it's inside of method A. So when we print that out, you get the value 25. Whereas in method B, we again declare an A variable, assign it the value of 3, print it out, and that's the value 3 would be printed to the screen. So a little bit more of a visual explanation or demonstration then of the concept that we just took a look at. And hopefully you understand it better now, because you can see that what's happening is that we actually have placed those values in two different memory locations. So even though they have the same name, physically in memory, they're at two completely different memory addresses. So method A's variable is at whatever that hexadecimal value is there, and then method B's variable is at a completely different memory address. So field variables now, these are not local variables. These are variables that are created outside of any method, so they're available to any of the members within a class. As we mentioned earlier, when we're doing object-oriented programming, they're created intentionally so that they can hold the attributes or properties of a class. Those are created in the heap memory. Local variables are created on the stack, so they're much more efficient. Field variables have an access specifier, what we call getters and setter methods, accessors and mutators. So if you see the code example on the right there, we have a private int myValue, and that's a field variable because it's declared outside of any method. So that belongs to the class console. And any of the methods inside a console can access then that variable because it's a field variable, not a local variable. So then we do exactly that. In the setValue method, you can see that we use that keyword this. So we're saying within this console class, go ahead and take that variable, myValue, and assign to it whatever the value of value is. When we call setValue, you can see that's being passed in as an argument. Then getValue, no argument being passed to it, but it just simply returns the value. So as we said, this is the getter and the setter here. So essentially, we haven't gotten to constructors yet, but when you create an instance of a class, you've seen that previously, we can go ahead and assign values to these field variables. In order to do that, if I want to assign it to the field variable, I would use its setValue method. In order to retrieve the value that's stored in myValue, I would have to use the getValue method. So setValue is the setter method, getValue is the getter method. This slide essentially just repeats what we were just talking about, just kind of adding a little bit more to it. So you can see that the field variable length in this case is being, the access modifier that's being assigned to it is private. So that means that only the methods internal to the class console can modify the value of length. So that's a key thing to keep in mind when you get to this level, which is more in the second class where you start doing a lot of object-oriented programming. But by making it private, you can't just call console and change length by doing console.length equals a value, or creating an instance of console for that matter and doing the instance.length equals a value. That won't work. What you would have to do is create an instance of console, but then use the setLength method. So it'd be, let's say C is the instance of console. So it'd be C.setLength, and then pass a value into that method, and then the setLength method is allowed because it's internal, it's a member of the console class. It's able to actually assign a new value then to that length variable, the field variable length. So we talk about overloaded methods. this is an interesting concept. You can actually create multiple methods that have the same name but have different parameters. And so that's what makes them overloaded. You have multiple methods being defined. They all have the same name, but each declaration has a different set of parameters. And so the reason that we do that is that we want to allow for that method to perform whatever its task is, but be kind of flexible to the type and number of parameters that can be passed into it. So the last bullet kind of reiterates that overloaded methods allows for the same task to be performed just on different data. This slide then shows an overloading example. We've created a method called average, and you can see that we've declared it here twice. In the first declaration, we're taking in two doubles and then returning those doubles being added together, divided by 2, because that's how we get the average of two numbers being added together. And then in the second declaration of average, we're accepting 3 different parameters, 3 different values, still of type double. Those 3 values being added together, but this time divided by 3. Because we're taking 3 in, we need to divide by 3 to get the average of those numbers. So the name is the same for both methods. So as a programmer that's going to want to use the class that contains this method average, I can just always know that I'm going to use average as the method that's going to return me the correct value regardless of whether I pass 2 values to it or 3 values to it. And of course we could go on and on from here. We could actually have another parameter that defines how many variables, or actually maybe do a count on the parameters to see how many values, maybe make it a little bit more sophisticated. But that's just a simple example just to get you to kind of understand why you would create overloaded methods and how you'd go about doing that. Now there is an issue that you might already be thinking about, which is which method is going to get called. It just simply depends on the method call itself. So if we pass 2 values into the average method, then the first method would be used. The one that expects it's going to get 2 parameters. If you pass 3 values in on the call, then obviously the one with 3 parameters is going to get used. So it's the Java virtual machine that will resolve that for you based on the signature of the method call. It just matches the call with the appropriate method. And technically speaking, each method is considered as a separate method, but because it has the same name, again, that just makes it easier, more usable. As far as having pitfalls to overloading, the main consideration here is that when you are creating overloaded methods, you want to be sure that you only overload methods that basically are performing the same task. So in the MPG method, you should always perform the same task in all overloads. Otherwise, unpredictable results would occur, obviously. So just getting back to the Java virtual machine, as far as which methods get called, the first thing that the JVM does is it looks for an exact signature of the name that you're using to call the method. And then second, it looks for a compatible signature. Digging in on that concept a little bit deeper here. So again, first, if we have an exact match, we're looking for that exact signature, then no argument conversion would be required. In the second case, where it looks for a compatible match, it's still looking for the same number of arguments, but the compatibility comes in with the data type. So we could possibly, in the example that we see down at the bottom there, take an int. If it's expecting 2 doubles, we could promote the int to a double, because there's no loss of data there. With demotion, which could occur as well, if you took a double and then demoted it to an int, then you may be losing some data, and that obviously could possibly cause some problems. So let's kind of take a look at this in example form. So here you can see that we've got 3 method calls, all calling void f. So nothing being returned from f, but f is the name of the function or the method. And in the first case, we've got an integer n and a double m being passed. The second case, we've got a double N and then an int M, and in the third case, a couple of ints. So let's take a look at this in a little bit more detailed example here. So if you have if you have a method that's overloaded 3 different times, the first one accepts an integer and a double M. The second one accepts a double N and an int M, so just the two flipped. And then in the third instance there, it just accepts 2 integers. They're still N and M. So if the call then is for the values of 98 and 99, then call 3, the third overloaded method shown here, would be the one that's going to run. In the second call, which is a double and an int, it's going to call number 2 because that's the format. If we have a call for 2 doubles, which one is it going to call? And that actually is a problem. So you want to avoid having that problem. You want to, in this particular example, if you expect that they might call 2 doubles, then you should overload it. You know, create an overloaded F that does take in 2 doubles, because at this point you really don't know if 1 or 2 is going to be called. The 3 wouldn't be very likely, but because they're both doubles, and 1 has a double as the second parameter and 2 has a double as the first parameter, you really don't know which of those 2 methods would be called. And depending on what the internal math is on it, the actual mathematical expressions, you could probably end up with a lot of different results, or unexpected results, and that's the big problem. So here we look at automatic type conversion and overloading. So when you're thinking about creating your methods, you might want to think about what we're looking at here, which is if you create parameters that are typically made of double type, that allows for ints, floats, or chars to be all upgraded to double type and really not have any particular issues with it. So it just kind of depends. I mean, if you know that it's absolutely positively your method's only going to ever process an int or a char or a float, you would do it that way, but just suggesting that you might consider always using doubles for your formal parameters, and that way you can avoid the problems that we were just looking at previously. So here you can see is an example of what we're just talking about. MPG, now we're using double for miles and double for gallons and returning the division of mile divided by gallons. So now we can have several different call types. So we can call MPG with 2 ints because it'll just simply convert it to 2 doubles. We can call it with 2 doubles, no conversion necessary there, or we could call it with an int and a double. So in this case, the int would be converted to a double and no need to convert the 2.4 to a double. Another interesting aspect of overloading your methods is the concept of one code path, because a lot of times what we'll do is we'll create a method that solves a similar problem, or actually a smaller version of a larger problem, and then we'll have another method that calls the first method to solve that larger problem. So I've got an example to show you which explains this a little bit better, but the idea is that you're creating a single code path, you're eliminating duplicate code, and it makes your code much more maintainable as well. So here's the example that I was referring to. So we've got some ASCII, meaning that we're going to add we're going to get a char value, and we're going to calculate its length. In the first method, you can see some ASCII takes in a string, and it's called strs, the value that we're going to use internally here. So what it does is creates a for loop that sums the characters in the string. If you look at the way the for loop is set up, it's going to run as long as I, which starts at 0, is less than the length, meaning the number of characters, in the string. So each time through the loop then, that variable sum, which is declared internally there for the method, is just using the plus equals operator to continually increase the value of the variable sum. And then notice too, there's a casting going on there where we're converting the char at value to an integer, which you do need to do since sum is of integer type. And when you do string.char at, you're basically getting a char value. Once that for loop completes, then the sum is returned to the caller. Now in the second method, notice that it doesn't have all the detail that the first method does. It takes in two string variables, two string parameters, but what it does is it runs the first method to get the actual integer value so that it can add those two string values together and come up with the sum. So this is the example then of that one code path. We're just simply overloading a method with the same name, has different number of parameters that are being passed into it. So in the second example, it's calling the first method, which does all the work. And that would be a lot better than putting all that code, copying all that code into that second method there. Because anytime you would need to make a change to it, you'd have to make a change to both methods. So study that, record that somewhere in your brain, because that's a very important concept when it comes to writing your code in a good, concise manner. That wraps it up for Lecture 7. We covered quite a bit in this lecture: how methods communicate with objects, how to create simple methods. We talked about building, creating your method headers, also known as signatures, declaring your methods, invoking, calling your methods. How the this keyword works. We showed you how to set up and use value producing methods, passing arguments to your methods, declaring a method's formal parameters. We talked a bit about SOLID principles, specifically coupling and cohesion. We talked about variable scope. Just remember that the variables you create inside of your methods are local. They're only available to the method where they're created. We talked about overloaded methods, and we talked about one code path. Until next time, happy coding. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.